taking the time during the holiday. Hello, whoever is on the other side of the world. So it's I'm William and John. So I'm professor at the university. So I'm also center director for the Center for Engineering, and also I'm involved heavily with NERIC. I've done quite a lot of work and be involved in project, which I will explain a little bit. But my background mostly is in mathematics and control theory. So I do a lot more on the mathematical side and mathematical modeling, and with application to robotics and energy, which is where my so from a system perspective, what I work with is mostly on developing the mathematics behind and the control systems, for instance, for robots. And then that's what we work for. So Lagrangian mechanical and dynamics.
I'm John Kelly, formerly Not So, if you knew me a month and a half ago. And I'm the technician manager at NERIC. So I do kind of everything, really. My background is primarily biotechnology, translational medicine, molecular biology. I transitioned into robotics a couple of years back. And I've been extremely busy ever since, working at NERIC on essentially. So I was big for this, primarily because I've got a good idea of what the team as a whole does, what NERIC as a group does, and our general future direction. So I'm hoping I can come away from here having given you an idea of that. If not, stop me and I'll do a better job.
So what we're going to do is John is going to present basically all what we do in NERIC and kit and material. I will come towards the end and says from the research perspective what we are trying to do. So I will just have a few words. Obviously, because what we'd like to do is to work with you and collaborate. I think that's what we are aiming. Not only give you a seminar, it's also really we would like to be involved as well with anything you would like to work with us. Well, from a robotics perspective, or any of the capability and facilities we have within the sector. So, John, I'll hand it back to you.
So I'll go through a few different things today. The general idea is to give you an overview of who our team consists of, what our facility actually contains, what the building is like, and what we're trying to move towards. As William said, the idea is that we give you enough of an idea of what capabilities we have that we can plan future work with, because that's where we want to go. And I think the better we understand one another, the easier it will be to collaborate. So if at any point you've got any confusion or concerns, stop me and I can answer questions. There will be a space for questions at the end, of course, but always happy to hear anyone. So thank you for coming. This is all about the North England Robotics Innovation Centre. We do a lot of work with the Boston University, but the focus will be on our building, our equipment, and our team. So that being said, what are we actually for? The university realised a while ago that there needed to be significantly more outreach into industry to get a greater percentage of our research outputs having a direct commercial effect. There's an understanding that some of our income has to shift away from the classical student model to other means of generating income for the university. And as you yourselves know, the university could benefit a great deal more from more industry collaboration. There's also a recognition from the funding bodies, because this was originally funded by ERDF, the last tranche of funding before that was cut off, thank you Brexit, and RED and latterly GMCA, that the Northwest in particular of the UK and the UK as a whole has a very poor adoption rate for automation in general and robotics in particular. The larger businesses already are generally quite automated where they can. The facilities often aren't there in small to medium-sized enterprises, even though the market is now open to them and has been for the last 10, 20 years because there is equipment that is within their affordable range, hasn't picked it up. It's not really been, well, it's accelerated more recently, but historically, the last 10 years has been on the order of thousands of industrial robots rather than tens of thousands. And a lot of that has boiled down to an inability to find good advice. A lot of these businesses do want to adopt anything that will give them a commercial edge, but there are no non-partisan organizations historically that are really advising them. There are vendors, but the vendors will give them solutions that they have, not necessarily the solutions that they need. And they're usually in line to specific robotics businesses. So they will sell their equipment, not all types of equipment. And NERIC was founded on the principle that we should have a broad spread of available technology from available suppliers so that we can give people a reasonable oversight of the industry. So that's what we mean when we say one-stop shop. It's supposed to be giving people the best possible consultancy to develop the business, to make new products, to hire new people, to get new processes, to really pick up the pace of automation and innovation in the Northwest. Now, moving swiftly along, I'll get on to a more detailed breakdown of what that exactly entails. Just bear with me and we'll get there. So it's an £18 million facility. The building itself is essentially 3 large labs and a series of conference and meeting rooms. There's a lot of space for getting businesses together for consultancy in workshops and similar. The large labs themselves are themed around different applications and services. Lab 1 is primarily and principally manufacturing, some food, a lot of pick and place operations, a lot of optical systems. Lab 2 is called the Intelligent Mobility Lab, mobile robots of various kinds and stripes. And again, I'll detail what is exactly there. Lab 3, they call it the Smart Mobility Systems Lab. It's a training lab and a metrology lab, primarily, measurement lab. There's a few different systems in there that fulfill that purpose. But of course, we're not bound to just the equipment of the building. We also work with Makerspace and other parts of the university to not only assist them, but to use their equipment and their specialisms, because we're supposed to be an inlet for business to the broader university as well. Because we're supposed to straddle between commercial and research. That's what we're for. So, this is the team, most of it. Some exceptions, unfortunately, but I'll give you a quick overview of who is what and what is who. In the top left up there, that is Mazian Azad. He's just taken up the post of director quite recently. And if you don't know him already, he's a physicist in the C School. He teaches microlithography and runs the microlithography lab that we just paid for and is currently being assembled. So he has a number of surrounding and specialist areas and already has some contacts with the business, which we're hoping to make a lot of use of in the future when he gets back from leave. And we can start integrating his specialties into the team. That horrible mugshot is me, unfortunately. I'm the technician manager. I lead the technician team, and the technician team works on the usual roles within labs of maintaining the labs and maintaining the equipment, but also works on the deliverables to clients. So, brief summary that we will return to. Clients go into us, we assign them a package of work. A technical consultant, several different people, designs a program around what they think they need and what we deem them to actually require for what they're saying they want for their business to grow. And then a mixture of TCs and technicians actually do the work required to make that happen. So as with every small team in the university, you have an assigned role and you have the jobs you actually do. So it spreads out quite a lot. A lot of TCs come with technicians on training courses and seminars to use the equipment, and a lot of technicians deliver technical consultancy work because that is often how it breaks down. So, we have here our first TC. This is Mike Bridges-Brown, mechanical engineer. He has worked in a wide variety of businesses, well over 100 now at this point. We get a lot of businesses through our door, so our TCs are spread across a diverse number of areas. He also works a lot in lean manufacturing and the delivery of a lot of rapid prototypes. We do a great deal of prototyping for business, whether it be of products or of parts for processes that they then build into their process later. Top left is Rebecca Tate, our operations and finance officer. Mid left is Nicola Ronan, our project manager. Person who has run our EIDF and red deliveries up to this point. Middle of the left is Tabs Kajani. Tabs Kajani is our business development manager. We get a lot of businesses through NERIC, and quite often we pass them off to other parts of the university for other commercial work or other specified tasks that they think they need help with if we aren't to do that. Basically, everybody goes through Tabs. And we are on the hook for our funding. We're on the hook to get through a set number of businesses in any given quarter, and they have to have certain criteria they have to meet. So we have to have them checked to make sure they fulfill the criteria for the funding. And then afterwards, we have to check that they have gone on to fulfill their requirements that our funding needs us to fulfill in order for us to get the grant money that we've been assigned. So a lot of that falls to that. Next, we have Dr. Matthew Southgate, he would insist. And he is another technical consultant on our team, specialist in computer science, specifically visual systems. He's done a lot of development with a wide variety of visual systems and the algorithmic tracking of motion within those fields. He is spread across more or less every project that we do. In all likelihood, in the happy event that we do build a project out together, he will be consulting on it in some aspect or another, just because of his depth of experience. Very useful man to know. Next in the line, we have Khan Ural, just finished a master's research within the school under University of Delhi. He is one of our 2 technicians, and he has worked a lot with aerial drones and programmable logic computers. A very good technician and a very useful member of the team. Helped us develop our recent 2 sets of new research pieces, one a palletizing robot and one a new research and torque measurement arm, which we built largely in-house. So moving down the line, bottom right, we have our other technician, Reza Farhadi, mechanical and electrical engineer, extremely good technician and extremely useful member of the team. Spends quite a lot of time doing subtractive manufacturing. We have as you'll see shortly, we have a very large 7-axis robotic routing cell. We do a lot of rapid prototyping with it, and a lot of that work goes his way because he's got considerable experience working in that area. Next in line is Edwin Diaz. He is our ATC, Assistant Technical Consultant. Fundamentally, his work is largely the same as that of the ATCs. He has somewhat less experience, but he has delivered the better part of 100 different projects to different businesses from different works and areas, and has worked on research projects with members of our research team. So again, we all wear a lot of hats. I'm sure you do too. Next, as our final technical consultant, Wolf Sargent, and he is a mechanical engineer who's worked primarily in lean manufacturing. A lot of our assists to business go the way of improving a process, trying to engage automation in a way that means that they are using fewer staff for the same process. And frankly, that is what a lot of them want or very badly need, because a lot of SMEs, we found, develop a process to deliver a product or service, and then they never review it ever again. And as the business grows, they get into recurrent habits, and then you have someone like Wolf go and analyze the work they're doing and come back with suggestions to make a greater number of products to market or a more efficient process that saves them cumulative money and time. And bottom left is our operations manager, Simon Plum, who takes care of every part of the building that is not my building. Again, a very helpful man and a very profitable organizer of projects and programs. All the documentation that we use in-house was written originally by Simon. Right, that's the team. Thank you for your patience. And we shall move on to more detail. So the facility is only a couple of years old. It was built by the same company, Morgan Sindall, that built the C building, and built it about the same time. The facilities were designed and picked with the assumption that we would be using university facilities in addition to the ones that are present in-house. So we tried not to replicate too much equipment that's already present in the university. That meant rounds and rounds and rounds of purchasing. But in the end, we got, as I described earlier, the 2 manufacturing labs, the intelligent lab, and then what is essentially the industry footprint training lab. There is also a great deal of working space. We get groups of SMEs in for consultancy days, essentially. So we have a large co-lab space, meeting rooms, breakout spaces, that sort of area. Good for exactly this sort of meeting, actually. So if you're in the need for a place that isn't PL, yeah, here's a show. Now, I've talked a lot about the businesses we're trying to help, and obviously, currently we're funded by GMCA. and the GM in that part is Greater Manchester. We are working with Greater Manchester businesses specifically. What they don't require us is to work with a specific type of business. So we have run the gamut. We've worked with an awful lot of small manufacturers. We've worked with people making veterinary equipment. We've worked with warehousing logistics companies. We've worked with plastics and injection molding groups. We've worked with video and media companies. We've worked with more or less every industry we could get in contact with. That does mean a very broad base. Because we're a fairly new organization, we've not started a great deal of specialization into areas that we're hoping to specialize with over time. But we have had the advantage of working with enough industries now that we know broadly what many of them want. And we have also been able to hand off a lot of business to other parts of the university, which has been quite good for us. Because there are many things, obviously, that we're not equipped necessarily to handle. But we're also equipped to reach out to business, and many parts of the university are not. So it's been a sort of give and take. Now, fundamentally, we're supposed to work in robotics automation, and we do have an awful lot of robotics equipment. Our duty to the university is sort of split, where we're supposed to reach the commercial work, but also improve and involve research. So we work with a lot of researchers within the university, trying to draw them in to use our equipment. And then we want to use that research to enhance our equipment on site and to enhance our offering to business, with the goal that in 5 years, 10 years, our equipment is very specialized towards specific areas of industry that we can help with in terms of robotics and automation. And people will know that our facilities are focused in such a way that they will seek us out. And it should be a familiar idea to you, particularly as an organization that already does something similar. We are still trying to bring in research, because our research team historically has been quite small, because we're a fairly new facility. So a lot of the equipment that we've got, we'll have to rework around new research projects, which is something we're really looking forward to doing, something we try and push quite hard for now. So this is the slide that we show to every single business. And I have heard these words said and have spoken them so many times that it has become second nature. A lot of our equipment is for mitigating tasks that people either don't want to do, can't afford to do, or do not have the time to. A lot of it is pick and place operations, generally so-called, or sorting, using visual systems or automated jigs or various different approaches. So the 5 Ds, our BDM calls them on a daily basis: dull, dirty, dangerous, dear, and difficult. I can't guess how many times I've said those words. And it is a fairly accurate approach to a lot of the things we tend to do. The robotics that we fit out for clients, the robotics that we fit in for research are as cutting edge as we can make. The robotics that clients generally want are not that. Most of them want reliable, they want cost effective, and they want something that is reasonably straightforward to institute, especially for small and medium-sized enterprises. They have neither the time, nor the budget, nor the inclination to spare staff time for the engagement of new equipment and new training processes. They want to seamlessly move something into their line of work and then have it just work. So the picture you're seeing on the right there, for the record, is our pick and place cell. The arm on the left is a SCAR GP88, and the little one on the right is an HT20. The number, for those of you who don't already know, you probably do, is the load capacity. So the 88 picks up 88 kilos, the 20 is 20. All the robots are named in a very similar format. It's one of the very few things the industry agrees upon. Right. So moving along, asking past this, have the general idea, but yeah, a lot of our work is de-risking, because a lot of people really just want good and clear advice on what's around the market. We're more and more now, we're also trying to push to bigger businesses our specific areas of focus, because we want to be able to start moving. Want to start producing a pipeline between our research areas and our commercial delivery. But we're still committed to delivering our GMCA requirements, because that's what keeps our lights on. So right now, the funding model goes this. We have 2 phases of funding for businesses. The first one is essentially to go into the business, to speak to them about what their current issues are, ask them what their current processes are, work out what they're currently doing, and then help them with what they think is important and what we think they could benefit from the most. That's usually 12 to 15 hours of work, and it's usually just a technical consultant. They go to sites, they do a delivery, they give presentations on what these people need. Sometimes there is some rapid prototyping, 3D printing, subtractive manufacturing, something fairly straightforward, but GMC hours for a fairly short contact window. So there's only so much we can do in that time. The longer phase ones can be anywhere up to 60 hours. And that usually involves a much more in-depth process. We're usually helping them develop a product, helping them redesign a process, helping them redesign equipment, redesign a piece of equipment we have in-house for one of their processes. So a lot of the time, for example, if we're working with a company that makes and produces flapjacks, we've done that one twice now. We take their product and we take photos of their working spaces and equipment, and we design or redesign a piece of our equipment that would work in that space. For example, for packing. And then we build a process that would work, and we demonstrate it to them, and then we explain in detail the steps we took to get there and what we would recommend for them to do, whether it be using equipment similar to ours, slightly different processes, different recommended vendors that would help them get to that point. That's straightforward. Generally, any research project is, well, a research project. So things can and do go wrong, but we've gotten very good at dealing with research. We've been doing this for a few years at this point. So it's worth mentioning that our ERDF and RED models, the details of how the packages would load were slightly different. The timescales, the nature of the work was largely the same. So that's it for commercial work. Let's talk about what we actually have in-house. So our lab one is manufacturing and food. And one of the first purchases, I believe the team that did the purchasing for our building made was for a large-scale pick-and-place cell. There's a few things on this image that are worth noting. So input and output lines, conveyors, go into the cell, and the entire thing is caged off. It's in a big mesh cage because it's an industrial arm. We have a few different what's called collaborative robots. The collaborative robots are the nice ones. You can put your hand out, and the collaborative robot will stop. The industrial robots are blind to the world and the work that they do. This one is the sort of thing you get in an automated manufacturing plant. And they will go straight through anything that they consider a barrier. So the entire thing is caged, and there are input lines in and out of the cell. And this is essentially a sorting warehouse. So on the inline, you have a conveyor that is stopped under two different camera systems, one mounted to the arm and one positioned above the conveyor. The one mounted to the arm can recognize the outline of objects. The one above the conveyor can give you depth, shape, and can do some fairly clever algorithmic measuring to work out dimensions and mass of items. From those two data points, you can teach the system to recognize products as they come in, and then the arm will sort them into the trays at the back. You can then put a request to the cell. It will check quantities and locations, and then put things onto the output conveyor. So what you have is a sorting and delivery system. It's a small warehouse. And the point of a lot of this equipment was not just that it had a clear purpose to business. It was that it's modular. There's nothing stopping us from taking these things apart and reusing and repositioning them, which we already have to some extent. We had a business come in looking for waste sorting. So there are lots of different ways you could sort waste. In summary, you can do magnetic screening, coarse screening, sieve screening. You can do it by mass, you can burn it. But if you want to sort, for example, plastic bottles, because it's easier to get them at an early stage than dig through the shredded and burned remains, then what you need is a vision system. And traditionally, the vision system has been mounted in someone's face. You have 8 people stood around a conveyor sorting from the line, and they do that in 8-hour shifts all day, which is as fun as it sounds. So we taught the vision system that hangs over the conveyor, which was a Mechmine DLK, to recognize the outline of certain types of plastic bottles. And with greater data sets, you get greater accuracy, but it was pulling those out of the waste stream and separating them so that a human being didn't have to do it, frankly. You see facilities that do that exact sort of process. They have banks of these set up and do it at a large scale. The process is the same, but ultimately the idea is that it saves you from, and I hate to say this, something that is dirty, dangerous, and difficult. So we do reuse parts of these in various places. The original cell had 2 arms in. The small one was fitted to be used for packaging and packing. But we learned quite quickly that a lot of the businesses that are coming in had different needs. So the little arm that was in the cell was removed, and we built a new cell around it. So a lot of companies, especially those small ones, what they really want, what they really, really want, is to never have to put something on a pallet ever again. So we took that arm out, we developed, we designed from the bottom up and built a PLC-driven palletizing cell that is just a conveyor, an arm in the middle on a post, and a pallet on either side. Something gets onto the conveyor, the sensor at the end trips and tells the arm there is something there to pick. The vision system on the arm finds the item, picks it, checks to see if there is a pallet. If there isn't a pallet, it doesn't move. If there is one pallet, it palletizes onto the pallet. If there are two pallets, it splits between them. That is who knows how many jobs that people have wanted. But we've had a lot of use out of the cell constantly. And again, it's another one we reconfigured. In addition to the GMC work, we also take consultants and commercial work. So we have a business I am not allowed to name, who currently have a requirement for essentially machine tending. So this has been a thing that's come up for us a few times, and we've redesigned the palletizing cell at the moment to operate, to load cartons and insert cardboard for a packaging machine. Because previously they had one person on a night shift come down once every hour and a half and reload a conveyor full of cartons, which is a miserable job, and they were paying that person quite a lot of money to do it, and he had 3 other jobs to do. So we're designing a process at the moment whereby we depalletize these cardboard cartons and load them onto the conveyor as it runs down. Nice and simple, right? It's taken 2 months so far. But at the end of the day, that is something a machine should do. And it does have a pleasing synergy of a robot managing another robot, which I always enjoy. It has use cases here. We found far more than they're actually on here. Again, they were designed to be modular. So we've taken this apart, we've reconfigured it on a couple of different occasions now. The whole design of the cell originally was that it was supposed to be piecemeal. So it's fairly easy to do that. So we redesigned it around research projects that we've had in. We had an Innovate research project where a company that was disassembling the motors in electric cars, which are, it turns out, not designed to be disassembled in any reasonable way. It wasn't a part of the design. So the process for disassembling currently is incredibly manual. Every part of it is just done by a human. The spindle in the center of the motor has to be pulled out manually. The casing has to be separated out. Everything is hands-on. So we built and reconfigured the cell, changed the tool landing a bit, and then reconfigured it so that it would identify the type of motor it was looking at, shift it to one side, pin it into one of several different jigs, clamps essentially, and then rip the core out. And those things are very heavy and very immobile. And it was a lot of this company's work was just disassembling these things before they could start recycling them. So one of our first pieces of funded research was doing that for them. And then we rebuilt the cell again afterwards because it didn't work anymore. So next one, cobot trolleys. So cobots, like I mentioned before, collaborative robots, robots that are meant to be easy to use. The last robot, the big blue one in the cell, runs largely off ladder logic, lots and lots and lots of linear instructions, or using things like Robotics or ROS and ROS2 intermediary softwares that you can use to control them in a slightly more simple format. But SMEs, businesses don't really know how to use those systems. A lot of the time, if you come to a business and they want to set up a process quickly, the best thing to do is to give it to them simply and have them do it. The collaborative robots are programmable by taking a hold of the robot, dragging it around. You drag it to a point, you press a button, you drag it to another point, you press a button, and it would just path between those positions on the loop. And you can program them iteratively that way, quite a long way. You can also set them up, and it's hard to see in this image, but you can set them up to change their own tooling. So you've got the different tool ends, vacuum grippers, just finger grips, screwdrivers, and sanders, various different tools. You've got a few others than that, box tapers, like an injection gun for silicon sealing. And you can set them so that they'll follow a tool path, change a tool, do another process, change back, and just keep going. They're also tied into vision systems so they can recognize outlines of objects. The big one for us, and one we've never had to disassemble because there's so much call for, is actually the sanding. So you can grab the arm, move it over, for example, wooden surface that needs something over, carbon fiber, everything it's doing, in a complex workshop, and it will just follow the path. You can set the number of newtons of force it will apply to that surface, and it will just keep doing that. If you've ever done any sanding, you'll see why that was an appealing option for so many businesses. And again, these are collaborative robot arms. They're 6-axis arms. The 6-axis arms are most of the ones we have in here: base, shoulder, elbow, and 3 different wrist motions. And they are preferred for us because they are flexible. Often for businesses, it's the less preferred approach. We have 2 arms called selective compliance autonomous robot arms, SCARA arms. And those ones are 3-axis, a shoulder joint, an elbow joint, and basically just up and down. And for a lot of applications, certainly manufacturing and assembly, they're preferred because they are simpler, so there's less to go wrong, more energy efficient. And whilst the 6-axis arms can move quickly, 3-axis arm can move even faster than that. So they're very, very rapid. And they generally use things like putting drugs into the plastic containers that usually come in, or rapid assembly of stacks parts for the mobile phones. So you have a conveyor between a set of SCARAs, and they're just loading from the bin onto the parts tray as it goes through, and at the end of it, you're going to assemble the product. They're also, for robotics, and I realize this is generally a fairly new field in the history of fields, they're fairly old. So not technically innovative, but a lot of businesses don't know that they exist or that they can use them. So a lot of the time we've been introducing people to technology that they didn't know that they could use. And as with the flapjacks, for example, you're bringing them in, showing them what is there, and showing them how they can use it and where they can get it. So moving on, we also have a welding cell. My BDM will be furious at me if I don't mention this. There is a global industrial shortage of welders. So a lot of companies were making welding cells, but we decided to make our own. Design our own. A company called Poma built it for us. And all it is a collaborative robot arm that you can drag around and a welding gun. It does take welding. And one thing we've done relatively recently is get to the point where we can take a CAD model, load it into the software. You can mark a seam on the part, and it will automatically design a path to follow that seam. So the idea for these is that you've got things like industrial boilers, and there are some very fiddly welds on that. And if you're familiar with welding, it is an art half the time, not a science. But there are many welds on there that are very linear, very straightforward, and which shouldn't require a person to do. So you can have a robot like this do the simple and standard work, and then have a more experienced human being do the tricky parts. And part of the reason we decided to build this ourselves was that we wanted to see what you could get it for. These things only cost us, for us to construct, £60,000 to £80,000, which in the grand scheme of things for a company that does a great deal of welding is a pretty good bid. Again, as with everything else, the entire thing is reconfigurable and reworkable. We did work for a company called MBDA relatively recently. We took all of the welding stuff off, fit several new sets of cameras on, and had it tracking sockets. So we were connecting different parts together on PCBs, and we were using QR codes that we mounted to the table, tracking relative to those, and coupling different coupling types together. Again, you can use anything for anything, and the very kind people who spec out welding in the first place try to make it as easy as possible. Also worth noting, that arm is from Mitsubishi. The last one you looked at was Jaka. The one before that was Yaskawa. We have Universal Robotics arms. We have KUKA arms. We try to spread across the industry as much as possible, and there aren't that many manufacturers. So getting as many as we did was kind of a coup. I think the only one we're really missing is Fanuc, but I'm not going to lose sleep over that. One fewer programming on which to learn. Right. So I should mention, missing a slide here. So we covered most of lab one there. All of them were manufacturing all of the food ones. There's one more robot in there, which I've not got a slide for, which is called the Delta. Imagine, if you will, a big upside down pyramid. The Delta is a very specific use case robot. It's usually used in food, and what it does is sorting. So you have a long conveyor, you have this upside down triangle of a robot mounted on 4 piston arms. It's mounted on the 4 piston arms to be accurate and to be as fast as possible, because it basically, when things come down the line, fruit, eggs, light bulbs, it will pick them in a set of different types of soft gripplers and move them off the line if they're no good, orient them to the correct position if they are good, and then allow them to be sorted further down the line. It's very common in food manufacturing because, frankly, there's a lot of variable size and shape objects, and there's a lot of different types of textures and surfaces that need to be picked quite gently. And we have an arrangement with a company called Piab at the moment, who have given us essentially a Lego kit of sushi cups. So it turns out that for more or less every product that you can possibly realistically imagine, they have developed and are developing different types of sushi cups, different ones for avocados, different ones for picked bags, different ones for opening bags, different ones for eggs, different ones for different sizes and types of eggs, different ones for different types of fruit, different ones for different ages of fruit. And what they do is a series of different modular cups that they put together that usually get mounted onto a delta for exactly the simple work. So we have an arrangement with them whereby we talk to them about new clients coming in, the sorts of picks they need, and they recommend to us from the big kit that they have provided different kinds of sushi that we can put together to make it more efficient bond. We don't generally recommend businesses, we don't recommend them, but they wanted to, well, get involved. They give us another sushi cup, so I'm going to argue. Right, so moving along to the next lab. So this is actually lab 3. The kit here was made by a company called Festo Didactic. And what it is essentially is a PLC, programmable logic computer, if you don't already know, training kit. So there's a few different units, one handling pneumatics, one handling fluid handling, one picking, placing, one sorting, one assembly, and one large station that basically goes from end to end, picking phone cases, measuring them, drilling them, and sorting them into different containers. And the entire thing is, our program manager described it once as a dollhouse version of a warehouse, of a manufacturing facility. Every aspect of it, when we got the kit, didn't work. You had to program every step of it all the way, and that's the point. If you can find in software where every light and every conveyor and every suction cup and every sensor is, and you can convey to the PLC the instructions required to do a useful process, and you can do it on a machine this big, you can do it in a factory that comes along with 300 of them. The logic is the same. The PLCs are generally the same. Ours ones are Samsung ones, but the logic is the same for all. And the only difference is the scale. We were starting on the development of a training program to bring companies in. That's not finished yet because the guy who's designing the program unfortunately moved on. But that's still the goal. And also we've used this more than once now for research projects because it is a very good way of generating large data sets quite quickly. Because there's a lot of sensors, there's a lot of outputs, there's a lot of inputs, and you can make deliberate errors that you can then get data from. So we've had a fair bit of interest from this, about this from within the school. Suggestions, of course. Moving on. Next one of interest, I think, to you will be the mobile robots. So the mobile robots, in this case, are warehousing robots. It's a fleet of 3 robots, a AMR 100, 250, and 600. Again, the numbers are the masses that they can take. So our smallest one, down here in the bottom right, that's a conveyor. The next one up has a 6-axis cell on the back with suction grip, and the next one up lists pallets. And we have half of our mobile robots lab given over to these, and they're actually surprisingly intelligent. They've got LiDAR and they've got ultrasound scanners, and the first day we got them, you can remote control them. So I drove one around the lab for about 20 minutes. And while I was doing that, it built out a map of the lab using the sensors available. It detected where there were hazards, it detected where there were things that already existed, it picked up the walls, it picked up the curtains, it saw through the glass windows and picked up the corridor, which is actually inconvenient. You had to remove that again afterwards. And then once you've got the map, you can stick nodes on the map. So dock here, charge, pick up pallets from here, go to here and check if there is a box to pick up on the 250. And also the conveyor systems that they could automatically access. And then from there, you can build up more complex instructions. Go to dock when you're at 20% battery, but only this robot is no longer moving. Go to this position when the previous robot is reported to the fleet software, the pallet's been dropped off so you can pick up. and you can build up more complex systems. And the idea behind this was that a lot of small and medium-sized enterprises don't have ideal warehousing spaces. Amazon have these things, and their ones are beautiful because they're all the same. We went and looked. What they've got is a floor of their building that is in a big cage. There are hundreds of them inside of that, all identical, all much simpler than these, because no one goes inside of the cage. When you put an order into Amazon, the AMR goes to the edge of the cage, and a person takes the items from the top of the AMR, and then it goes back into the fleet. Most people don't have tens of millions of pounds to build a custom space for their AMRs. These will work more or less anywhere. They're very battery efficient, and they'll map out a space. So if you're in converted Victorian warehouses, a lot of businesses in Manchester seem to be, or you're in what was formerly a restaurant and you're reworking the space for warehousing, you can map the space and use it within a day. You have an automated warehouse that will work straight away. And because these ones have got quite a lot of sensors on them, they detect when people are there and will path around them. So you can have them in a space where human beings are working, provided they can hear you, or you can hear them. And they're equipped with various lights and sound producing devices to give people advantages in those circumstances. But it's certainly a lot easier than traditional blind AMRs. Slightly more expensive inevitably, and more complex, but efficient and reliable and usable swiftly in a lot of working spaces. There's a lot to talk about that, but I should move on for now. We can come back to them. So, everyone's favorite robot. This is, we have regular talks inevitably with business, with researchers, with students. And this is the one we always end on, simply because it's the one that people have the most interest in. But we have a Boston Dynamics spot. If you're not already familiar, and I apologize if you are, it's a quadrupedal inspection robot, essentially. It's got two forward-facing cameras, one on each side, one on the back, a LiDAR, and another camera inside of the gripper. Those are generally 2 megapixel cameras. It has sound detection and it has auto stabilization. So this robot, without any adjustments or reconfiguring, can walk upstairs. It has programs built in automatically to open doors. We've used it to call the lift in our building and get the lift up itself. It will carry things and self-stabilize the arm when it's holding something, so the body will move, but the arm will stay static relative to the body or relative to where it was holding it. And we've used this for research as well, because this robot, as well as being designed for varied environments, industrial environments, it was originally designed for search and rescue, as a lot of robots generally are, because it's a very easy field to get in when you're looking for mobile robots. The advantage of this is that it's looking in every direction at once. So we had a researcher come in a while back with an algorithm for detecting whether or not industrial vibration was undoing bolts. And they had a vibrating plate essentially with a bunch of different hexagons bolted into it. And we just had this robot walk on an autopath for about 3 hours, back and forth in front of the plate. We took the visual feed data from it and handed it over to it for analysis. It's ideal for that sort of. We can also use it for a number of other things, but to be honest, it is primarily a inspection robot, and it is a security robot for robotic purposes. I think SpaceX has two for analyzing the underside of the rocket nozzles after they landed, because it's too hot to send a person on. One thing we didn't mention is also the metrology equipment. We have 2 metrology scanners. We have a Creaform HandyScan Black, measures things down to 23 microns, 1.3 million times a second to deliver really rapid mesh of items. Initially for QC, but for us, we used it for rapid prototyping. We used it for taking models of things that were obsolescent. In fact, we took it to a meeting of the Obsolescence Society down south to show them how useful these things are. And for rapidly iterating products and checking tooling to see its degree, also different applications. We also have an optical one now, which goes to a lower resolution, but works on a much larger scale. So where the Creaform usually measures things you can fit in your hands, you could scan a room with the one we have now and get quite a high degree of resolution and a consistent model, which is useful for a lot of things. I realize I'm getting along, so I'm going to speed up a little bit because we're getting to the end now. Obviously, we have the equipment on campus, which we also introduce our clients to. Part of the brief of our facility was that we're supposed to interact with the university proper and get as much involvement as we can, which we're trying to push more and more because it's a sensible direction to go. And there are a lot of pieces of equipment in the university that could be better utilised by business or by international business. So that's something I'm going for more and more. And that should bring us close to a close. This is me. If you want to get hold of me, the full name of because I got married last month. And if you knew me by a different name, apologies, I'm not trying to be awkward. If you want to message us after this about anything, or if you just want to come in and look at the equipment that we've got, or have a longer talk with myself or a TC or any of our colleagues, just drop our email online and we'll sort anything out. We'll make time. Please just let us know. That's it.
Thank you. Just to be clear as well, so John has presented what we've got here in NERIC, because where we do a lot of research as well. So what we are looking as well is to engage, we work with industry, that's where we want to work in research. So for instance, we have a colleague in computer science, again, to see us, just to give you an example, for maintenance, you know, when we have a production line, you want to make sure that everything is okay and there's no quite to predict any potential fault or diagnosis. That's one. We have system as well that we can use for research to develop EPSRC. But we also do KTP, Innovate UK, this part of the research, and as well the potential of having potential PhD student as well working in NERIC, developing basically working with us in research. Obviously, I'm looking for myself, we have control systems, but in the other area as well, we can work with. So last time Antonio gave a seminar to NERIC, and it was really good. And we could see there were some synergy between the centers, so between acoustic and NERIC, and I think there's a great potential here to work using robots. So for instance, idea we were floating is when you're in manufacturing sector, so it's having robots working around, being, you know, the sound, a bit aware, the awareness of what robot is around. Sometimes it can be dangerous. So this is something we were, you know, IDs, for instance, but there may be others we could think of from robotics and automation perspective. Anyway, this is why I wanted to open this to make sure we open to business. Thank you.
Great. We've got a bit of time for questions. Anyone's got anything?
Yeah, it's maybe a vague question. Do you do much work with the School of Health and Society? I'm just kind of thinking that the huge area of the NHS is kind of reducing the amount of people that they need because they can't find them to do all sorts of things, or give out like something that might measure people's blood pressure or check their ears or something while they're waiting in the waiting room at the surgery, that sort of thing.
So we have at least one ongoing project with Professor Stephen Crease, looking at developing equipment for the Health and Society School, because he had equipment on hand that needed rebuilt, recalibrated, recertified, and frankly understood. And we have also had conversations with people within Cockcroft and teams within Cockcroft, because there is a lot of equipment there that could benefit from a greater degree of automation. And we want to assist them in doing that. It's where I came from for a start. And also, they are eminently aware that there are lots of areas where that is being sought after, but they don't have expertise, and we want to help.
So we also have a project that's currently finishing. We have an exoskeleton. So exoskeleton, it's basically a frame for people to have it walking. So this is basically you put that around and then it adapts. It's an intelligent exoskeleton to adapt to the person. So we have a project currently working in that. It's very similar to robotics, because in effect that's what we are trying to do. And me myself, I work on electrical stimulation. So what is electrical stimulation? Is to restore motor function, stroke, for instance, or paraplegic. And what you do is you've got two electrodes. So for instance, the heart, got two electrodes, and you stimulate the muscle. And so basically it's like imagine this is the muscle fiber, and then what you are trying is really it's like pulling basically it's exactly the same. This is what we are trying to do. It's very similar to robotics. We don't control robots, but we control the motion of a person because they suffer stroke. So when you suffer stroke, basically, patient have atrophy within the vessel. And now we are trying to use the vessel so they can grab something and use a control system. Very similar. So we don't control a robot, we control a person for them to do the motion. So this is kind of also area we are interested in. So,
Thanks.
We've got one question online. Lorenzo, if you want to unmute yourself.
Oh, sorry, just a quick one. Do you reckon that the idea of creating robots that can collect plastic waste from rivers or ground is achievable?
Yes, it is. It requires careful thought and preparation. You can't just put a robot on a boat in a water stream and have it sort waste directly. Generally speaking, the best thing to do is to increase the density to increase the rate of capture. And you've got to have it in a situation where if you're using optical systems to actually find that sort of thing, you have it the best opportunity to get good capture data so you can retrieve plastic and other materials successfully and consistently. It is a good idea. It does work, just has to be done right. And then it has to be assessed to see if it can be done cost effectively, which is a different problem entirely. But yes, great question.
Great, thank you.
that's a good idea. Thank you.
Actually, on the waste thought, are people developing robots that would sort and strip plastic off copper and that sort of thing for recycling?
We do. We have a colleague, for instance, who is involved in a European project doing exactly this, doing robots, sorting out the plastic and sorting out within the wasteland involved. There's quite a few projects as well where robotic systems are involved in waste management. That's really, so we have a colleague as well, Theo, who's working on that, but I know this is quite a few, quite old area. I've been looking.
I was thinking kind of being part of a research organisation, you've got maybe the opportunity to actually make that a circular thing so that the outcome of that robotics investigation into recycling things then goes back to the manufacturers so that they understand how to put the things together so that they can be taken apart automatically.
So I did recently, last week, I submitted a Horizon EU on biomass and which is circular economy. So this is something I just submitted last week. So this.
There's a company called Seike in Partington, not far from here, and they make cardboard. They make paper for cardboard. But a lot of their waste stream contains a great deal of plastics, and it comes from various different sources. But they have been working more and more into sorting, because traditionally what they do is they dissolve all the paper particles they've got, and everything else gets scraped out, sorted, shredded, and ends up in an ERD, an energy recovery boiler, which they class as biomass, which they use to drive a 20 megawatt generator. But the waste stream has been traditionally coarse sorted. It's the finest of 1990s technology. So you ran a magnet over it, then you ran it through a series of sift screens. Then anything you couldn't separate that way, you shredded and burned. And they're looking into doing exactly this sort of thing because a large chunk of their waste stream they want to sell back to themselves, which they were already doing to some extent, because the less they shred and burn, the more money they can make, and the less waste they put to landfill and they have to treat for pH intolerances, etc. It's a really good idea. It really is.
I guess we've got quite a lot of those sort of things in Manchester, in the Greater Manchester area, where you can actually move the stuff around.
Exactly. And to reuse them, recycle.
So one of the area of what we can see, or what we've seen industry coming to NERIC is increasing productivity. So, and we have quite a few projects where, so there's one we are putting an application for getting go away myself on code. You know, the code that you see on the road,
Yeah.
The way those things are annoying when you have to drive. So this company are using, they are painting those codes. At the moment, it's done by someone, but the loss of paint is enormous every single day. The people they use a gun and they painting with a gun, but so they want to reduce the amount of losses using robotics. So this is one example. Another project we had, it was on food. So it's a company who produced a container where you put the food for the animals. So they eat the food and they can eat the container. So this is part of this. And the mount is all done. It's a machine that individual machine, and it's done, but they have to carry from one machine to another, to one machine to another. They can only produce 2,000 units per month. And the demand is so high, they could produce 20,000. Again, this is another example where robotics and company around and surrounding Manchester are really looking really to increase that productivity, which basically, without saying sometimes, how it's go there because they pay someone, so they say they could reduce someone the cost of someone. But this is something which we always try to reskill the people who basically where normally in that position they should be reskilled. That's what we are trying to help them.
Thinking from a safety perspective, I did a short stint factory work in a cake factory and looking at picking and sorting machines and thinking flapjacks and the manual handling injuries associated with those sort of industries are quite high. And that, I mean, I'm going back 45 years, that really hasn't changed. Got a friend who had an accident recently in Greater Manchester in a factory, got his hand crushed. And that was literally, again, it's the manual handling. It's that bit where the machines don't actually deal with each other. And there's this kind of gap in the middle that you shove a person in doing something that is really not good for the person and it's the 5Ds.
Yeah.
And there must be so many places in Manchester, in Greater Manchester, that have those issues. It's getting them to you and you to them. I think is part of your challenge.
This is what the NERIC is all about. This is what we're trying to do.
It really is. It's pushing people up the technological readiness level tower. You're right. A lot of the manual handling tasks haven't really changed in decades, and it's the same problem. But a lot of people are spending their entire working lives moving boxes of between 15 to 20 kilos from one conveyor to a different conveyor or to a pallet into a box or packing.
Yeah.
Not only is it a supreme waste, it's bad for them.
Yeah.
And
I think that's the.
And there are a lot of Manchester businesses we found it's a choke point. It caps off the amount of production they can make because they can only ship and sell so much, so they don't produce them. So they're sort of trapped standing on their own hands. So for a lot of businesses we worked with, it's just, as William said, it's about scaling up the productivity by getting rid of a few bottlenecks. And more often than not, it's not that they don't want to do it. They don't want to have 8 people stuck on the conveyor. They just don't know what facilities are available, how much they cost.
But please feel free to come to NERIC. Please contact us. We'll be happy to give you a tour.
Yeah.
It's really it's open.
Yeah, I missed out when you visit, unfortunately.
That's fine. I mean, please let us know. We'll give you a tour.
And if you've got any particular equipment you want to look at or get further into, we'll make sure it's up, available and ready to chat.
And ready to ready. Yeah.
Cool.
Well, thank you.
Adam, thank you very much.
Thank you.